Hello, welcome to Maths with EJD. In this video, I'll be talking about generalized Fourier series. Okay, we already know that a Fourier series is a way to represent a periodic function as a sum of sines and cosines. That's the fundamental thing about Fourier series. Okay, then we need to also know that a Fourier series decomposes a function into its frequency components, into its frequency components, making making it easier to analyze and manipulate. Okay, so the standard form, the standard form of a Fourier series for a periodic function f of x, the periodic function f of x, right, is f of x equals summation from n equals minus infinity to infinity of cn e raised power I n w naught x. Now we've seen something close to this in previous examples, but because uh, the key thing here is that we're focusing on the generalized form of this Fourier series. So this is just like a kind of reminder of things we had done in the past. So let's focus now on the generalized form. So generalized form. Okay. So the generalized Fourier series extends this broad concept, extends this concept, this concept extends this concept to broader classes of functions. Specifically, for non-periodic functions, we use the Fourier transform, which I already demonstrated in, I think, maybe 2 videos before now. You can check that up. We use the Fourier transform. We use the Fourier transform which represents the function in terms of continuous frequencies. So the Fourier transform Fourier transform in terms of the Fourier transform of a function f of x, which we have also seen before, right, is f of omega equals summation from minus infinity to infinity f of x e raised power minus omega e raised power minus I omega x dx. So this gives us the Fourier transform like we've seen previously. So now this transformation maps a time domain, maps a time domain, a time domain signal with maps a time domain signal into the frequency domain. I made an example. I did an actually a worked example the other time. So into the frequency signal, allowing us to understand its spectral properties. Okay. So the generalized now the generalized Fourier series can be applied to functions in different spaces, such as distributions, which might not be suitable for standard Fourier series. For standard Fourier series. So the standard Fourier series is designed for translating periodic functions into sums of sines and cosines. But so we got the generalized form can actually take care of functions that are not necessarily periodic. So let's take an example to finalize this idea. Look at this example. Imagine we consider the function f of x equals e raised power minus x squared, which is called a Gaussian function. It's a Gaussian function. Okay. Its Fourier transform, is given by f of omega equals, in fact, I think I want to write it on a different line. Its Fourier transform is given by, so let me change the color. So it's given by f of omega equals integral from minus infinity to infinity of e raised power minus x squared e raised power minus I omega x dx. Now, if you solve all this, you end up getting square root of pi e square root of pi e raised power minus omega squared over 4. The process is a very lengthy one. So probably one of these days, if I get to teach special functions like all the gamma function, beta function, and the rest of them, we might come across this there. So, but this is this for now, the Gaussian function. So, this example This example illustrates how the Fourier transform can represent a non-periodic function, or represent a non-periodic function in terms of its frequency components. So you see that the function that we are dealing with, which is f of x equals e raised to power minus x squared, is non-periodic, but then we can use the Fourier transform to get it into its frequency components, which Fourier series is meant to do originally. So that's that about this particular video, in talking about generalized Fourier series. Okay, in the next video I'll be talking about Fourier series in higher dimensions. So if you have not subscribed to this channel, you want to do that right away and hit the notification bell so you can always get alerted each time a new video is released. Then you also want to comment, let me know how helpful these videos are. Also, let me know if there's a problem you'd like me to solve or a topic you'd like me to teach. Like and share also so that more people can have access to this great content. Till I come your way again, have a nice time. Bye.